So the frequency of oscillation is given here. We are going to derive these two things, F naught and HFE. Okay, we are going to derive the expression for frequency of oscillation and the gain which is to be produced by the circuit for sustained oscillations. So Z1, you know, it is going to be inductor, so j omega L1 plus j omega M. In case of mutual inductance, if you have, Z2 is j omega L2 plus j omega M, and Z3 is capacitance 1 by j omega C or minus j by omega C. So we have these three values for Z1, Z2, and Z3. So we are going to go back to our equation. We have written the general equation for oscillations, right? So we are going to go back to the equation, substitute the values for Z1, Z2, Z3, and we are going to simplify. See, you need not consider mutual inductance here. For derivation in your exams, Z1, Z2, you can consider without M. And finally, in the expression, you can say if M is present, how the formulas are going to change for F naught and HFE. That is, in that way, you can say, because you lot of terms will come if you include M in the expression for F naught and HFE. So one smart way of doing is don't include M in the derivation and include M finally in the equation. So this is the simplified expression you get after substituting the general form of LC oscillator equation. So you have a specifically a real term and you have an imaginary term. So the imaginary term will be having a J component and real term will be a real number. So for finding the frequency of oscillation, usually, you know, we will equate the imaginary term to zero, because at the frequency of oscillation, the circuit is a pure resistance. And we have said the phase shift is 360 or zero, right? So which means that the reactance part is completely eliminated and it becomes zero. So take the imaginary term and put omega on omega equal to omega naught and equate that to zero. So this bracket term becomes equal to zero. So L1 plus L2 plus 2m minus 1 by omega naught square C will be equal to 0. So if you simplify, you get F naught equal to 1 by 2 pi root of L1 plus L2 plus 2m into C. So this is the frequency of oscillation you get in the Hartley, and you get plus if the windings are going to have the same dot notation. If the windings are going to have a different dot notation, which means, see here, if the current entering through one inductor is here and the current entering through the other inductor is here, then you will get plus 2m. If the current entering to L1 is here and the current entering to the second inductor is here, then the dot conventions are different, so you get minus 2m. L1 plus L2, you can get plus or minus 2m. Plus is for the same dot convention, minus is for the different dot convention. You would have been studying about all these things in circuit theory, about how this M will be, the sign of mutual inductance will be playing a crucial role when you apply KVL to a inductively coupled circuits. And we have equated the imaginary term to zero. So now it is the turn to equate the real term to zero and put omega equal to omega naught to find the gain offered by your circuit. So the real part, you have this term. So omega square into this term. So this bracket term will be equal to 0. L2 plus M into 1 plus HFE minus 1 by omega naught square C equal to. So if you simplify, you will get HFE equal to L1 plus M by L2 plus M. This is for the condition when the dot conventions are adding. The dot conventions are different. It will be L1 minus M by L2 minus M, because the mutual inductance will be out of phase from the original inductor value. So this is the derivation for your Hartley oscillator. So remember, I again said this in class. If the question is asked for 16 marks, Hartley oscillator completely in part B, then you have to derive this general form of LC oscillators in a very shorter form and then concentrate on your Hartley oscillator. 16 marks means 4 marks for general form of LC oscillators, 12 marks for Hartley oscillator. 12 marks plus 6 marks will be for your diagram and explanation. 3 marks will be for deriving the frequency of oscillation F naught, and 3 marks will be for the deriving the gain of your amplifier. Okay, so this, I again say, these oscillators you read in parallel Hartley It's unclear because the general form of LC oscillator derivation is going to be common for all the three, and all the three oscillators will differ only from the circuit diagram and the expression for F naught and HFE. Otherwise, the principle of operation, generating oscillations, everything is going to be the same for all the types of LC oscillators. So you mostly in the question they will not give M. So in that case, M will be 0. So HFE will be L1 by L2 and F naught will be 1 by 2 pi root LC where L is equal to L1 plus L2. That's all. In the question specifically, if they give mutual inductance, then you have to use the formulas involving M. So HFE will be L1 plus or minus M by L2 plus or minus M, and F naught will be 1 by 2 pi root of LC where L is equal to L1 plus L2 plus or minus 2M. So depending on whatever value of M you have given in the question, you have to substitute them and you can solve the problem for finding out F naught and HFE.